Dear students, this video lecture deals with drawing circle on your monitor screen. As in previous lectures, we had studied to draw a circle using equation and using polar coordinates. This time we will learn another algorithm called midpoint circle generating algorithm. It's an very efficient algorithm. You will see how it will increase the speed of drawing a circle. So before starting this algorithm, we need to know a few things. First of it is to test. We should be able to test whether a point lies inside circle or it is outside. This can be achieved by using this function called f circle. So f circle gives you an idea whether a point xy lies inside the circle or it is outside the circle. So you fill these values in this polynomial x square plus y square minus r square. If this value comes out to be less than 0, means it is negative, then the point xy will be inside the circle. Similarly, if the value comes out to be positive, means greater than 0, that will mean that the point is outside the circle. And in the third case, when this value is exactly equal to 0, that means the point lies on the circle. Apart from this, you need to know the octant symmetry. By octant symmetry, I mean that if we draw a line and cut the circle from on this line and fold it through this line, the both the parts of the circle will exactly overlap. Similarly, if we draw a line along, we fold the circle along this line, and the both the parts will be overlapping each other. Similarly, the circle has symmetry about all these lines. Uh, as the two-dimensional space is divided into 1 2 3 4 5 6 7 and 8 parts, so this is known as octant symmetry. If we draw a point, if we find out the coordinates of a point xy on the circle, let us suppose this point lies on the circle and its coordinates are xy, then by simply changing these values, doing a little of change in it, for example negating the value of x, getting minus xy, will be another point which will be on symmetrically opposite the y axis, and it will be lying on the circle. And if we negate the y coordinate of this, means we get x minus y, we will have a point which again will be lying on the circle. Similarly, if we negate both the coordinates x and y, to make it minus x minus y, we will get a point which again will be lying on the circle. Similarly, if we swap these coordinates x and y and we get yx coordinate, this point also lies on the circle and it is opposite to the circle along this line. So for this xy, you have another point yx which also lies on the circle. Similarly, now we here it is to be kept in mind that y is not the y coordinate. Actually, the first part of this point is always x coordinate. This is just value. So value of these two coordinates is reversed. So for example, x is 3, y is 5. So this is 3 5 and we reverse 5 3. But 5 is the x coordinate and 3 is the y coordinate in this situation. Similarly, out of symmetry we can find four more points. If we negate this y, we will get minus xy. Similarly, if we negate this value of x, we get y minus x, and similarly minus y minus x. Means to say that if we are able to calculate one point, we will get another 7 points in bonus, making it 8 points. So our task is just reduced to calculating the coordinates of the point lying along this part of the circle only. we will start from the first point, and its coordinates will be 0 r. Very obviously, it is the origin of the coordinate system. We move 0 in x direction and r, which is the radius of the circle, in y direction. So coordinates of this point are 0 r, and we will start finding out points next to it. We will do it in a recursive way. So that means that from the first point we will calculate second point, and when we have done with the second point, we will calculate third point from it, then fourth, and so on. And we will stop at the location on which this the point which lies on this line will have coordinates x equal to y. So our loop will start from 0 to r. X will increase and this coordinate, y coordinate, will decrease. So we will go in the beginning, this is x coordinate is less than y, and similarly as we move on, x will increase, y will decrease. So a situation will arrive where both the coordinates become equal, and beyond this point the x coordinate will be larger than y. So we have to stop here. So the loop will go until x is less than y. So let us suppose we find a point whose coordinates are xk, yk. Just a minute. Let us suppose we have calculated a point whose coordinates are xk and yk, and we want to find out the next point, the point next to it, whose coordinates are xk plus 1, yk plus 1. Therefore our task will be finding out this point from this point. So we have to calculate these values, and we know these values. So let's do some mathematical work to find it out. I divide, let us assume that xk, yk is the point which we have currently calculated. Now the next point to it will be either this or this. In this case, as you can see, that locus of the circle passes nearer to this point, so we will choose this point, and for this point x is incremented by 1 and y is the same. So this is the case 1 where xk plus 1 is equal to xk plus 1 and yk plus 1 is unchanged. Similarly, if the circle is like this and we have calculated this point, now you can see the locus of circle passes nearer to this point instead of this. So in this case we have to opt this pixel, and coordinates for this pixel are xk plus 1 and yk minus 1, because with the reference to this point we have moved one step in the horizontal direction, therefore xk plus 1, and moved one step downwards also, therefore decrementing yk. So this point has coordinates xk plus 1 and yk. So in the second case, our new point will be obtained by incrementing x and decrementing y. As in the earlier case, where case 1, x was obtained by incrementing y by 1, but y was unchanged. So now this as this data is not represented on the screen, your computer have to calculate the values. So let's do some mathematical work to find it out. So this decision of case 1 and case 2 is based on midpoint. For example, in case 1, this is the case 1, if we find midpoint of both the candidate points, we find the midpoint of both the candidates is its coordinates will be xk plus 1 and yk minus half. This is yk minus 1. So these are the coordinates of the midpoint, and in case 1 this midpoint is inside the circle. So if we fill these values of coordinates in the f circle function, and we can judge whether the point is inside, that is pk value of this equation xk plus 1 whole square yk minus half whole square minus r square. If this value comes out to be less than 0, then the case is identified as case 1. In this case we will increment x and will not decrement y. Case 1 is identified through this. Similarly, case 2 is identified by the midpoint. In case 2 this midpoint is outside the circle, as you can see from the diagram. So in this case the same value of decision parameter will be greater than 0. So from these two values we calculate pk. If it is 0, if it is less than 0, then we will choose the upper point, and if it is greater than 0, then we will choose the lower point. In both the points x is incremented, but y is, in case 1 y is not decremented, and in the second case y is decremented by 1. So this decision parameter will decide whether the next point will be calculated by decrementing y or not. Now calculating this decision parameter every time will be a tedious task. Calculating this equation, this expression every time will be time consuming. Therefore we do some mathematical work to find out a recursive equation for this parameter, so that calculating decision parameter becomes easy. For this I have equation for the decision parameter as xk plus 1 whole square plus yk minus half whole square minus r square. If I replace k with k plus 1, so I get this equation p k plus 1, so k plus 1 instead of k. Similarly, this k will be replaced with xk plus 1, and this k will again be replaced with xk plus 1. So I get this equation. So in this equation, if we are dealing with case 1 in which pk is less than 0, xk plus 1 is xk plus 1 and yk plus 1 is unchanged, means it is equal to yk. So when we simplify this equation using a plus b whole square and replacing xk plus 1 by xk plus 1, so we get xk plus 1 whole square plus yk, because yk plus 1 is equal to yk, so this becomes yk minus half whole square minus r square. So in this equation now I apply a plus b whole square and I get this. Similarly, this part of the equation is written as such, and same here. So after a bit of simplification you can get whether when we subtract these equation this, call it a, and equation this, call it b. So a minus b gives you this parameter pk plus 1 minus pk is equal to this part of the equation will be subtracted from this, so therefore this will be cancelled out. A lot of terms will be cancelling out. Yk plus minus half square will cancel out, r square will cancel out, so you will get a simplified version of this differential equation. Pk plus 1 minus pk is equal to 2xk plus 3. If we rearrange a bit, this minus pk will shift on the right hand side, and we will get pk plus 1 is equal to pk plus 2k plus 3. Now this equation is the recursive equation for finding out decision parameters. Suppose we know decision parameter for 7th point p7. Adding these two values, these two known values to this decision parameter, we can get decision parameter for the next point p7. So adding this parameter, it is quite easier than calculating pk every time using complex equation. So this equation pk plus 1 is equal to pk plus 2xk plus 3 will give you easy calculation of decision parameter from earlier value. To start, just a minute, let's discuss the case 2 also. In case 2, the recursive equation for finding out the decision parameter varies a bit, because in this case pk is greater than 0 and x is incremented and y is decremented. So we will use these values. So decision parameter for kth point is this, and similarly to obtain a recursive equation for decision parameter, we replace k with k plus 1. We get this equation, and afterwards we replace these values. Xk plus 1 is equal to xk plus 1 and yk plus 1 is equal to yk minus half. In this equation we get this, and after simplification, after solving the a plus b whole square etc., you get this this plus this minus this. Now similar to earlier procedure, we find the recursive equation of decision parameter by subtracting equation A, equation B from equation A. So A minus B will give you a similar kind of equation, but it will have a bit difference in the parameter. Actually minus 2yk is the difference and plus 1 instead of plus 3. So rearranging this pk on the right hand side, you get another decision parameter equation in the recursive form. So first of all we will identify the case. If it is case 1, then we will use this recursive equation for finding decision parameter for the next point. And if it is case 2, then we will use this equation for decision parameter for the next point. But where to start? Just a minute. So decision parameter for the very first point can be calculated using this information. So as we know, the coordinates of the first point are 0 and r. Therefore filling this value in the decision parameter, which is actually f circle at this point, so xk will be replaced with 0 and yk will be replaced with r. So after filling this into the f circle parameter, we get 1 square plus r square etc. After simple calculations we get this equation, 5 divided by 4 minus r. If you are running your program at turbo compiler where using C or C++, then 5 divided by 4 can further be simplified to 1 if we are taking integer calculations in mind. So 1 minus r. So decision parameter for the first time can be calculated using equation p0 is equal to 1 minus r. And afterward we can if p0 is less than 0, then we can find p1 from p0 using equation, just a minute, using this equation. So p0 plus 2xk plus 3. I'm having some problem with my slide. So, and similarly, if this is case 1, and similarly in case 2 where p0 is greater than 0, then p1 can be calculated from p0 by adding the equation, adding parameter which we had found out in earlier equation. So from p0 we can calculate p1. Similarly, when p1 will be positive or greater than 0 and negative, so this is case 2 and this is case 1, again you can find out p2 from p1 plus something. And similarly, if it is in this case, this we have equation for finding out parameter for this also. Similarly, we can find out p2, and further we will go on p2. If it is positive, if it is negative, then we can find out p3 from p2, because we have now the equation, recursive equation of finding out the decision parameters. Using this we can find out the decision parameters until we need, and this will go on until x is greater than y. So now have a look at the summary of the algorithm. First of all, you will demand input from the user. What is the radius of the circle? So if r if r is the radius of the circle, then we move on to the next step. In the next step, we find the first point of on the circle will be having 0 and r coordinates. This should be comma, not full stop. And afterwards we will calculate the decision parameter for the first time, called initial decision parameter. This is equal to p0, and it is calculated by using this equation 1 minus r. Now two cases arise. First, in the first one, if pk is less than 0, coordinate of the next points will be, x will be incremented and y will be same, and along with it we will calculate the decision parameter for the next point also. So decision parameter for the next point will be calculated by adding pxk plus 3 to p0, right? And in the second case, when pk is greater than 0, means pk is positive, in this case x is incremented and y is decremented this time. So the next point will be obtained by incrementing x and decrementing y if pk is greater than 0. And similarly, decision parameter for the next point this time will be calculated by adding this factor to the earlier decision parameter p0, and we will get the bonus points by finding the octant symmetry. For example, the point we got is 3 5, then we will have point 3 minus 3 5 and 3 minus 5, etc. We will get 7 additional points, and you have to repeat these steps from step number 4 to step number 8 until x is less than y. Whenever x becomes equal to y or x exceeds value of y, then this loop will stop, because by then we will have reached at the point which which was lying on this line. So we have reached this point if x becomes equal to y or x is greater than y. So you have to stop there. So you have by now calculated these points and these points also along with the other points out of symmetry.